Okay, today we are continuing where we left off yesterday. We started with exploring the transformations that we are doing today. The transformations we are learning today will be able to be applied to other parent functions like a quadratic parent function, square root parent function, cubic parent function, etc. So what we're learning today is building the foundation for several more units to come throughout the semester. So, the parent function, here's the equation. F of x equals the absolute value of x. So remember those vertical bars being absolute value, which is the distance from 0. So the first thing we're going to do is fill out the table. So for the x values, I want you to fill in -3, -2, -1, 0, 1, 2, and 3. So those are the x values we'll be using, -3 to +3. Now to get the y values, we need to substitute those in for x. So if I put a -3 right here, what is the absolute value of -3? 3. What's the absolute value of -2? Absolute value of -1. Absolute value of 0. Absolute value of 1. Absolute value of 2. Absolute value of 3. 3. Now, we need to plot all 7 of those points on the graph. So the first ordered pair is -3, 3. Then we have -2, 2. -1, 1. 0, 0. 1, 1. 2, 2, and 3, 3. And if we did the math correctly, and if we plotted the points correctly, you should have a V. So go ahead and connect those points with the right arm and an arrow going up, and the left arm and an arrow going up. Now the vertex is going to be the point at the top of the V or at the bottom of the V. So for the parent function, we're talking about this point right here at the bottom of the V. And we need to write this point as an ordered pair. So what is the vertex written as an ordered pair? Yeah, the origin is 0, 0. Then today on all of these, you'll be asked, is it the maximum or the minimum? So what you need to do is look at your vertex. And you need to decide, is this point the highest point on the V, or is it the lowest point on the V? Lowest. So if it's the lowest point on the V, then it is called the minimum. Just circle the word minimum, because it's faster to circle the word versus writing it on the answer blank. And yesterday we learned that the domain for all of these absolute value functions is always what? Negative infinity to positive infinity. And we can't touch infinity, so both of them get parentheses. Range. What does range mean? The y value. So looking at the vertex, what is the y value down here? 0. And the y values go all the way up to infinity. So the range is going to be 0 to infinity. 0 gets a square bracket because we can't touch the 0, and infinity gets the parentheses. Now the x-intercept. Where does this V touch the x-axis? At 0. So our answer is x equals 0. For the y-intercept, where does that V touch the y-axis? At 0. So this would be y equals 0. Now, remember what the parent function looks like. Its vertex is at the origin, and to get the other points on the V, we go up 1, over 1, up 1, over 1, and it does point up. Now, at the very top of your handout, you have this equation, and this equation is called vertex form. So it has f of x equals a, inside the absolute value is x minus h, and behind the absolute value is the plus k. I'm going to write down a few things. for us to know about what do each of these values do to our v, or the parent function. So if the a value, if the number out front is a negative, do you remember what it makes it do? Yeah, reflect over the x-axis. So the a value can make it reflect over the x-axis. Yesterday we saw a 2 out front. Do you remember what the 2 out front made our graph do? Stretch. That's factor of 2. So the a value can make it stretch. And when we had the 1/2 out front, what did it make our graph do yesterday? Shrink. So the a value can make it reflect, stretch, or shrink. So the a value can do 3 things. Now inside the absolute value we have h. H stands for horizontal. So the h value will make our parent function move either to the left or to the right. To the left or to the right. And it's the opposite of what you would think. If it's a negative, which way would you think, left or right? If it's negative, you would think it would be to the left, to where the negatives would be on the number line. But it does the opposite. It moves it to the right. If it's a positive h, it moves to the left. So inside the absolute value, it does the opposite of what you would think it would do. If it's a positive, it moves it to the left. If it's a negative, it moves it to the right. Now k, the number that's at the back of the equation, will either make your graph move up or down. So if your k value is positive, it's going to move up. If your k value is negative, it's going to shift your graph down. So today we're not going to be using any tables. We'll be looking at the equation, and from the equation, we'll be able to see what transformations have occurred, whether it moves left, right, up or down, if it's stretched, if it shrank, or if it reflected. So we're going to look at number 1, and looking at the equation, inside the absolute value, we have a -2. So if I look back at my notes, here is where the 2 would be for the h. And h, it tells me right here, the h moves it left or right. So if it's a -2, it does the opposite of what you would think. So instead of moving it to the left, it's going to move it to the right. So for problem number 1, this -2 on the inside will move it to the right 2. So instead of the vertex being right here at the origin, we need to move that vertex to the right 2 units. So instead of starting at 0, move it to the right, and it's going to start at 2. Now to get the other points on your v, you need to find the a value. So the a value is a number out in front. And what number should be right here out in front of the absolute value? A 1. I'm going to make the 1 into a fraction. I'm going to make it 1/1. And think of this as your slope. Technically, it's not slope. It's your a value. But think of it as slope. So back in algebra 1, the top number was the rise. The bottom number is your run. So from the vertex, I need to rise 1, run 1. Rise 1, run 1. Just like on the parent function. So from the vertex, go up 1/1. Up 1/1. Up 1/1. To get the left arm, do the same thing. Up 1 left, up 1/1. Up 1/1. Up 1/1. Make sure you show every single point. Don't just eyeball and say, here it is. You need to have every single point that I have on the screen. So I know it's tedious, but you need to show every single one of those points. And make sure you put the arrow so it keeps going up. Now the vertex. The vertex is this point down here at the bottom. And what is this vertex as an ordered pair? Be careful, what's the x value? 2, and what's the y value? 0. So the vertex is 2, 0. Let's skip down here to the fourth question, maximum or minimum. So look at the vertex. Is it the highest point or is it the lowest point? So if it's the lowest point, it's the minimum. Just circle it, you don't have to write it. Back to domain. We know the domain for every single absolute value is always what? Negative infinity to positive infinity. What does range mean? The y value. So down here at the bottom, what's the y value down here at the vertex? 2. The y value? 0. The y value is 0 and goes all the way up to what? Infinity. Which number goes first, 0 or infinity? 0. Small number first, large number last. Which one gets the parentheses? Infinity. The infinity. Which one gets the square bracket? 0. The 0. Then they ask us for the x-intercept. So where does this v touch the x-axis? At 2. So x equals 2. The y-intercept. Where does the v touch the y-axis? 2. At 2. So the y equals 2. Okay, next one. Looking at the equation, we have a -3 at the back. If I go back to my notes, what would a -3 at the back make it do?
Go right.
The number at the back makes it do?
Go down.
Up or down. So if it's a negative, it's going to move it down. So this one is going to move down 3 units. So instead of starting at the origin, we need to move it down 3 units. To get the other points on the v, we need to know what is the a value. So what number is out here in front of the absolute value? 1. And I'm going to make it 1 over 1, so I know the rise and the run. So from my vertex, I need to go up 1 over 1, up 1 over 1. And you have to put every single point to get credit. And fill up the graph. Up 1 over 1, up 1 over 1. Now the vertex, be careful when you write this vertex as an order pair. What's the x value there? 0 and the y value? -3. So 0, -3 for the vertex. Now look at that vertex. Is it the highest point or the lowest point on the v? So if it's the lowest point, is it the maximum or minimum? Minimum. Circle it. Domain. What's the domain for all of these absolute values? Negative infinity to positive infinity. The range. What does range mean? Y value. So look at your vertex. What's the y value down here at the bottom? -3. And it goes all the way up to infinity. So -3, comma, infinity. Which one gets the square bracket? -3. And infinity gets a parenthesis. For the x-intercept, where does this v touch the x-axis?
-3 and
-3 and
3.
+3. Here's one way you can write it. X equals -3, x equals +3. You can write it separately, or you can write it as x equals plus or minus 3. Now this is the way I prefer because it's less writing. And what this notation means, it means x equals +3, x equals -3. So if you use the plus or minus, it still gives you both solutions, the positive solution and the negative solution. And you have to have both solutions to get full credit. Now the y-intercept, where does that v touch the y-axis?
-3.
-3 for the y-intercept. Is y equals -3. Questions on number 2? Next one, number 3. We have the negative out front, so save that for last. And what's the plus 2 at the back make it do? Go up 2. So instead of starting at 0, move it up 2. So translations first, the A value is left. So move it left, right, up, or down. Now for the A value, what number is out in front?
-1.
Negative 1 over 1. So this is my rise, this is my run. So I need to rise -1 and run +1. So if the rise is negative, instead of going up, what do I need to do?
Go down.
Go down. So start at 2, and you need to go down 1 over 1, down 1 over 1. And put your arrow so this one points down. So if A is negative, it's going to point down. What's the vertex? 0, 2. And looking at the vertex, is it the highest point on the V or is it the lowest point? Highest. If it's the highest, is it the maximum or minimum? Maximum. What's the domain for all of these absolute values? Negative infinity to positive infinity. The range. What does range mean? Y value. So what's the Y value at the top? 2. What's the Y value at the bottom? Negative infinity. When it points down, you have to be careful. Out of 2 and negative infinity, which one is smaller? The negative infinity. So negative infinity goes first. 2 is larger, so it goes last. Which one gets the parentheses? Negative infinity, because we can't touch it. And 2 gets the square bracket. The x-intercept. Where does that V touch the x-axis? Negative 2 and positive 2. So I'm going to write that as x equals plus or minus 2. So x is equal to positive 2, x is equal to negative 2. And the y-intercept, where does that V touch the y-axis? At 2, so it's y equals 2. Any questions on the front? Moving to the back. Number 4, we have an A value of 2, so save the A value for last. What is the plus 3 on the inside going to make it do?
Go left.
Left or right? If it's a plus, it's going to move it to the left. So our graph, instead of starting at 0, 0, move it to the left 3. Yes, that 2 is going to make it stretch by a factor of 2. And I want rise over run. So how do I change 2 to a fraction? 2 over 1. So I need to rise 2, run 1. So I need to go up 2, over 1. Up 2 over 1, up 2 over 1 on both sides. What we're doing today will be on the no calculator section for test 1. I think test number 1 is Tuesday of next week. So I think it's review Monday, test Tuesday. And you will have a part of the test that's no calculator. So you'll have to be able to graph these without a calculator. Okay, what's the vertex?
-3.
Negative 3, 0. Is it the maximum or minimum? Why is it the minimum? It's the lowest point. Domain, what's the domain for all of these? Negative infinity to positive infinity. What does range mean? The y value. And at the very bottom, what's the y value?
Negative 3.
What's the y value here? The y value. 0. The y value down here is 0, and it goes all the way up to infinity. So it's going to be 0, comma, infinity. The x-intercept is negative 3. The y-intercept, where does it hit the y-axis? Right here at 6. So y equals 6. Next one, number 5. Save the A for last. And what's the minus 1 on the inside going to make it do? Move to the right 1. What about the plus 6 at the back? Up 6. So instead of starting at the origin, we need to move right 1 and up 6. So from 0, 0, go right 1, up 6. Now the A value we saved for last, what's the A value? Negative 3 over 1. So if the rise is negative, do I go up or down? Down. So we need to go down 3 over 1, down 3 over 1, down 3 over 1 on both sides. Make sure you put your arrow so it keeps going down.
I'm worried what direction.
Just do the best you can. What's the vertex?
1, 6.
1, 6. Is it the maximum or minimum?
Maximum.
Why is it the maximum? The highest point on that V. What's the domain for all of these? Negative infinity to positive infinity. Now when it points down, we're going to have to be careful when we write the range. So looking at the top, what is the y value at the top?
3.
Higher than 3. What's the y value at the very top? 6. It goes from 6 down to where?
Negative infinity.
Negative infinity. Now my answer has to be from least to greatest. So which one of those is the smallest?
Negative infinity.
Negative infinity has to go first. 6 goes last because it's the largest. For the x-intercept, what are the x-intercepts? Negative 1 and positive 3. So can I write plus or minus 1? No, because are they the same number? No. So here you can't write it compactly. You'll have to write both of these. So the first one is x equals negative 1. And the second one is x equals 3. So you can't combine those together because they're not the same number. And for the y-intercept, where does that graph touch the y-axis?
3.
3. So it's y equals 3. Okay, I want you to do number 6. Graph number 6. Answer the question. Number 6. Did you do number 5?
Yeah.
Look at your graph to number 5.
I just didn't graph it.
Yes, ma'am. Are you? you do number 6?
I don't remember what you did.
Do left one. Yes, that's right. And then you need to go right 1, right 2. So up 1.
How do you do number 6?
Move it left or right, move it up or down, A value is left.
Okay, that's 1.
Look at how much you were skipping. And your graph is supposed to go all the way down to the bottom. This is what's supposed to be 1. No, you have a 1/2 out. No. No. Here, this means you move it left 1. This means you move it down 1. So from 0, you need to move left 1, down 1.
I got it.
Here, the y value is -1. So it should be -1 to infinity. This is for Kyla. No, it's not. C109. Somewhere downstairs. I'm gonna check it. Find it. Hey, let's look at number 6. Okay, number 6. What does this +1 make it do? Left 1. What does the -1 make it do? Down 1. So do those first. Run 0. Move left 1, down 1. So your vertex should have been at -1, -1. Use your A value to get the other points. Your A value tells you the rise and the run. So we need to rise 1, run 2. So that means we need to go up 1 over 2, up 1 over 2, up 1 over 2. It makes your point. What's the domain for all of these? Negative infinity to positive infinity. For the range, what's that bottom y value? -1. What's the top y value? Infinity. Is that vertex the maximum or the minimum? Minimum. Why is it the minimum? Because it's the lowest point on that V. The x-intercepts are?
1 and -2.
1 and -3. So x equals 1, x equals -3. Doesn't matter which one you put first. The y-intercept, does the y-intercept occur on a whole number? No, so you'll have to estimate. That looks like it's where? 0.5, but if it's below 0, it would be -0.5. So the y-intercept would be -0.5. Okay, the last 3 3. Now we're going backwards. Now we're given the graph. We have to write the equation. So our equation needs to be in vertex form. Y equals A. Inside the absolute value is x minus h plus k. So for the A value, we need to see how much are we going up and over. So here's the vertex, here's the next point. We're going up 1 over 1. So what is the A value? 1. And then we'll have the absolute value. Then the x. Now h is horizontal. Did this graph move horizontally, left or right? Did it move to the left? Did it move to the right? No, so we do not have h. There's no horizontal movement. It did not move left or right. But the plus k, did the graph move up or down?
Yeah.
Yes. Which way? Up how much? 1. So I need to have a plus 1. Now when I write my equation, an equation must have an equal sign. So you do have to have the y equal. The a value, you don't have to have the 1. You have to have the absolute value. And to make sure that we know it's translated up 1, make sure you have the plus 1 at the back of your equation. Now, the last question right below that, they want to know for what value of x is f of x equal to 5. F of x means y. So they're telling you that when y is 5, what is the x value? So somewhere on this v, the y value is 5. Well, up here is 8, 7, 6. They're talking about this point right here. So when the y value is 5, what is the x value? -4. So x equals -4. Now that also occurs over here on the right side. So when the y value is 5 over here, what is the x value? 4. Well, I already have -4, so I'm going to make this plus or minus 4. So x equals positive 4, x equals -4. Okay, number 8, we need to have our equation in vertex form, which is y equals a absolute value of x minus h plus k. For the a value, find 2 points. So here's a point, here's a point. So we're going down 2 over 1. So what is the a value? -2 over 1, and I'm going to write that as just -2. Then behind the -2, you need absolute values. And then x. Now, h stands for horizontal movement. So looking at the vertex, does the vertex move left or right? No, so we will not have the h value. For the k value, does this vertex move up or down?
No.
No, it's at the origin, so it didn't move down either, so we won't have the k value either. So here's our equation right here. Y equals -2 absolute value of x. Last question asks us for what value of x is f of x equal to -6. What does f of x mean? Y. So we need to find the point that has a y value of -6. Let's see down here is -8, -7. Here's -6. So when the y is -6, what is the x value? -3. Now it also occurs on the right side. So on the right side, when the y value is 6, what is the x value? +3. So I'll make it plus or minus 3. Okay, I want you to do the last one, number 9. So write down the equation for number 9 and answer that question right below it. find the A value. So pick 2 points. Here's a point. Here's a point. So we're going down 3 over 1. So what's the A value? -3. Absolute value. X. H is horizontal. Did it move left or right?
Yes.
It moved left 1. So how do I show on the inside that it moved left 1?
Plus one.
Plus 1. K, did it move up or down?
Down.
Down how many?
2.
So what do I have to have behind absolute value? -2. When you write your equation, make sure you have y equals, or f of x equals, whichever. So it's y equals -3, absolute value, x plus 1 on the inside, -2 at the back. And for what value of x is f of x equal to -2? And what does f of x mean?
Y.
Y. So there's a point that has a y value of -2. So down here, it's -8, -7, -6, -5, -4, -3. They're talking about the vertex. So when the y value is -2, what is the x value? -1. Now what if they tell you f of x equals 4? Yeah, it's +4. Then let me erase what I have up here so that you can get a better look. So when f of x is equal to 4, what is x? Here's 4 up here. Is there a point with a y value of 4? No. So the answer would be none. No solution. There is not a point that has a y value of 4. So our answer would be no solution, which is that 0 with the slash.